It's 8 a.m., a Monday morning like any other. The tickets are already flooding in. 3 users, 3 different failures. One laptop is stuck on a black screen, a signature verification error. Another device boots, but the Wi-Fi never comes up. The third user is online, browsing the web, yet Microsoft 365 refuses to connect. You check the logs, no server is down, no outage reported, but for your users, everything is broken and nothing makes sense. This is not a coincidence, and it's not a random glitch. This is an architectural shift. For years, we treated security as a perimeter, something outside the system. But that model is fading. Trust is moving inward, deeper than the OS, down to the very foundation of the machine. We used to think patches fix problems. A bug appears, we patch it, and move on. That model is changing. Today, updates don't just fix issues, they enforce trust. Older secure boot configurations, legacy drivers, outdated DNS assumptions are increasingly being challenged in modern environments. And when they don't meet the bar, systems may not fail loudly. They simply stop being usable. It starts at the foundation, firmware. For years, UEFI was set and forget. But now, trust at boot is evolving. If firmware is not aligned with newer expectations, bootloaders may not be recognized as trusted. The result? A system that may fail to boot or recover, or deploy. A boot deadlock. If you can't trust the first instruction, you can't trust the system. Move one layer up the kernel. This is where the OS meets hardware. Stricter code integrity is now the baseline. If a driver fails to meet modern signing expectations, it will refuse to load. But it's more than just a missing driver. In a Boot 2 cloud architecture, a vulnerable driver is a Trojan horse. It can bypass OS protections and compromise memory via direct memory access attacks. Breaking the trusted chain before it even connects, the system appears up, but nothing works. No network, no VPN, no security tooling. A device that is technically on, but operationally unusable, fundamentally compromised. Then comes the most deceptive layer, DNS. Ping works, internet works, but cloud access fails. Because in modern architectures, connectivity does not equal trust. If DNS resolution isn't aligned with newer validation and trust models, cloud services may become unreachable, even when everything looks normal. This is where many teams get confused, because everything looks fine till it doesn't. We used to believe trust started at the network. We were wrong. Trust starts at the firmware level, and it extends across a continuous chain. Firmware, boot, kernel, drivers, DNS, cloud, each layer building on the previous one. Trust is no longer granted. It is continuously proven. Think of it as a bridge. It doesn't matter how strong the surface is. If one pillar is weak, the entire structure is at risk. A legacy driver, an outdated firmware, a misaligned DNS layer is no longer just technical debt. It's a break in the chain. For IT teams, this creates a new kind of challenge. Monitoring says systems are up. Users say they are down. Tickets increase. Signals don't match reality. Without visibility into these trust layers, you're not troubleshooting infrastructure, you're troubleshooting uncertainty. Adapting to this shift requires a different mindset. Firmware can no longer be ignored, it must be actively managed. Drivers must be inventoried and modernized. DNS must be validated against current trust expectations. And deployment pipelines must account for the entire boot chain. Because if you're not actively managing these layers, you're not operating a secure environment. You're operating on borrowed trust. This is not just a technology change. It's a redefinition of trust. Zero trust is no longer just a network concept. It is becoming a boot-tuck cloud architecture. And when it breaks, nothing looks obviously wrong, but nothing works. The real question is, are you still in control of your chain of trust, or did you already lose it without noticing?